Okay, day 3 of Advent of Code. So, didn't try it. I just have 20 minutes time to solve it. So let's start and go. Let's scaffold day 3. Okay, maybe if I go 2024, let's scaffold day 3. We have an input, we have the problem, and we have our text here. Our computer having issues, I have no idea. Okay. We have a shopkeeper at the North Pole rental shop. Any chance you can see why the computers are having issues? They appear to be trying to run a program, but its memory is corrupted, so all the instructions have been jumbled up. The goal is to multiply some numbers. It does that with instruction like multiply x or y, where x and y are each 1 to 3 digit numbers. However, some multiplication must be ignored, even if they look like part of a multiply instruction, like this. Okay, so we need to check for valid multiply operations. Consider the following, which is the example. Only the 4 sections are real multiply instruction. Adding up the results produces this number. See, can the corrupted memory? Okay, so I think we can solve this with a regex. So let's try doing that. I don't know how to do them. Let's see. So I can create a regex for the multiply. For example, here, let's write a test. So fn want to write a test to extract the example is this. Oh, it's the one in the examples, so I can just do this and read it from the example file. Let me start with a function extract mul. It gets a string. It returns. I mean, this is just solving part 1. Let's just write the test for part 1. So this is the example, and I need to get some number which is 161. Now let's solve part 1. Let's write a regex, which is no, this one is the one in the example. Let's see if I can use the regex. Yeah, it's part of the standard library, so it's fine. The regex should have a multiply. Then we have a parenthesis, which is part of the regex, and we have 2 numbers. A number is multi-digit number, so this one is the first. This one is the second. I don't know if I need the end here. Okay, so this is the regex. Let's see how to match that. Okay, we can captures with an iterator. Perfect. Okay, so we can do something like that. We have a result for, now we have 2 captures. So we have number 1 and number 2 in the captures of input. We extract it and we push this. This is a vector of unknown, and we need to put in one parse. I hope they are integers. Let's see. These are all integers. These are also integers, unsigned integers. So let's parse this 2. Let's parse this 1. Now it doesn't like it. Why? Okay, because we need to. Okay, so I want a back of U32 of pairs of U32, U32, and these in with the result, but I don't want the result. I just want to unwrap this. So let's just unwrap the result. Hope it's all fine. Unwrap. Still doesn't like it. because we need to return sum of results iterate map. Now here we get a pair of n1 and 2, and we can just return n1 by n2 and sum all of them. This should return something. Now why? We don't have a regex. Fail to resolve undeclared type regex because I need to use the regex. So use regex and use of the create regex. So add regex work now. So cargo test bin 03. Let's see if it works. It fails. That's way too. Okay, so we need to close this parenthesis. We didn't close it. Let's try again. Still failing. So let's see what are the results. Results are this one. They are 4. Are they the one we need? So 2 by 4. Oh, this is a 2. We don't need that. 5. Okay, so we are just getting n1. We're not parsing n2. Okay. That's because I did it wrong. Let's try again. We are getting sum of 161. So why is it not working? Because I put the wrong output. This is the one we want. Try again. Okay, let's solve the 03. We get this nice number, which I don't think it's the right one. So let's see again. Yep. Let's go to part 2. So this is part 2. As you scan, you notice that some of the conditional statements are also still intact. If you handle some of the uncorrupted conditional statement, you might be able to get an even more accurate result. Okay, so we have a new instruction here. Okay. The do instruction enables future multiply instructions, and the don't disables future multiply instructions. Only the most recent do or don'ts applies. At the beginning of the problem, more instructions are enabled. Okay. The corrected error is similar to the example, but this time the multiplies are disabled. Again, we need the sum of the results. So in this case, we need 48. How can we do that? Again, we have this, which is the same example, I think. It's not the same example, so we need to get a new. Let's just give it a string. In this case, the input is this string here. And let's solve part 2. So for part 2, we can either get a multiply, a do, or a don't. Now we could do another regex here. So we can embed any multiply into a don't, between the don't and the do. Yes. So between a don't and a do, we can just remove the multiply. So for example, here we need to remove this don't, multiply until the do, which is this one. So we can try with regex again. With a first regex, we remove the multiplies, and then we just solve for part 1. So let regex equal to regex of, we need a don't. So we need a don't written like this. Again, I think I will need 2 backslashes. Then we can have everything inside. We can have any number of parameters in here. And then we need a do like this. Now, every time we match, we try to replace this. How can we do that? With Rust. So replace, there should be a replace. We can try to look for replace. Simple capture group, simple replacement. Okay, replace all. For example, here we can say we can just replace the input and say that it is dot replace all of input, and this is what we need to replace it with, which is nothing. We get a new input and we return part 1 of the input, like this. Let's try. It's working. Nice. So if I solve it, I need to remove this debug here. Let's try again. And if I try to solve this and copy, then I get the application which is not working. It's not the right transfer, it's too low. Okay. So let's see this new input. This new input is let's try with the test. The thing is this passes, so let's see with the input. We have some multiplies, we also have some do and some don't. I think some are embedded. So, for example, let's test again. I want to test with some test cases for part 2. Let's try with RS test. With RS test, I have a first case, which is I want like don't. This is okay, like this. Then we have a multiply of between 4 and 2, and then I have a do. And I want sum of 0, for example. Now this is the test with some cases. And the case is first the input, which is a string, and then the result, which is an option of 32. I want the result and part 2 of it. Right? Working because I didn't import it. And here I didn't put the case here. Okay, let's try again with the test. Now this case here works. So let's find one that doesn't. For example, this. For this, we want to have 6 because it says only the most recent do or don't instruction applies. So for example, if we have a don't and then we have a do, this multiply should be enabled. So we should get 3 by 2, which is 6. That's why it's not working. Now let's try again. We need to have something which is not don't or do. Or maybe we just do not need to do this. We can just parse for the don't, for the do, or for the multiply. So we can try with another here, which is maybe we can just try with different results. Either this is either a don't, Yes. Either it is a don't or a do or a multiply. Or a multiply of two numbers, which is the one we already have. These are different capture groups, right? I don't think this works like this. Do we have ORs? Let's see on the regex 101 website. I don't. Yeah, there's a Rust regular expression. We have our example for this, like the input. I just want to check with our test case. So here, I just want to have. No, this is the input, and our regular expression is the one here. Okay, it's an incomplete capture group. Now let's capture that. So match 1, match 2, match 3. Like it? We don't have a third match for the do. So, oh no, we have a fourth match. Okay. Now let's make it better. This is a don't, or a do, or a multiply. We need one less. Now this captures the don't, this captures the do, this captures the multiply. Okay. So if we use this regex and try to capture them, we captures this and we extract them just like we did before, and we do it in a loop. So for examples, for something and the match, which is a word, an operation actually, in this. Okay, I need to put it into parentheses. Okay, in this extract. Now we can have again our multiply results. At the beginning they are enabled, so at the beginning it is enabled. These results are here. Now the operation and the mapping. This is a space and this is a string. If operation starts with do, so if this is a do, enabled equals true. So we can just match. Operation match do. I forgot. Operation match. So we need a do. I always forget which kind of arrows to use because I use .NET and Rust together. So if we have a do, then enabled is now equal to true. If it's don't, then enabled is equal to false. This is the wrong arrow. Forget. Let's see the match. Is the right. Last match string start. Oh, okay. So as string. It is already, but okay. Here it does. like this. Oh, the match is from .NET. Okay. So again, we match the operation string. We match the do, we match the don't, and we match the mul. Now, this is a string. We can try to just parse it, but I mean, let's do it again. I mean, we don't even need to do that. This is a form. No, we can try to capture it better. Come on. This is just a string. Okay. But we can also try to extract it better. So what if I have an OR in that? Unicode syntax of the composites. Okay, so how about the alternative? Yes, grouping of flags. Named capture groups. Okay. How does the caps work? Because we can just try to have this, and we can match not operation. This is a capture, so we have the capture, and we have capture get of 0, and this is our. So let's go back to regex 101 because it had the right structure. We have this regex. We have our example. We have the matches. So match 1 is a don't, and group 1 is don't. Now we have groups here, so we can get group 2 and 3. We don't have a 3 here. Okay, it reserves us something. Okay. So the 1 should have always something. No, 0 is always not none. So we can extract it and we can just map it. Map the default is this, and the function is the and as string. So this should not exhaustive, and I know, okay, it's okay. If I have a multiply, then we do results. If it's enabled, so if enabled, then results push of error, which is exactly this one. Now the parses are on the capture, and 1 and 2 we don't have them, but we can at least close this. And get is not 1, is 2 and 3. So 2, and we get C get 3 again. Doesn't work because the match needs to be as a string. This works. It's ugly, but works. And in the end, we return the same number. Now it passes. I just want to try to solve it. So we can go away and not this. Let's see if the website works. And that's right. So we just did day 3 of code. Now this is really ugly code. I don't want to refactor it. I have 5 minutes to go away and it's fine. So we will see later. So that was day 3 of Advent of Code. And that's it. See you.